keeps growing with age. And so you can get huge dinosaurs before the flood. In the earlier climates, possibly higher carbon dioxide levels, 3 to 7 times higher, greater plant growth, higher oxygen levels. Gigantism is linked to higher oxygen levels. They found dragonflies with 2-foot wingspan. So yeah, they could have gotten really big way back then. After the flood, rapid changes in climate and atmosphere, drop in oxygen levels maybe, possibly violent storms, lightning after the flood, destroyed vegetation, not enough for them to eat. Man could have hunted them maybe, I don't know. After the flood, that's when God told Noah, you can now eat meat. And so maybe man destroyed them. I don't know what happened to them after the flood. Dinosaur bones and tracks. Usually whenever you find the bones, they suggest catastrophic entombment. You find them a lot in debris flows. They're always mixed with other bones, and so that indicates probably flood conditions. Billions of dinosaur tracks, but they're always like they're trying to get somewhere or away from something. You never just see tracks where they're wandering around or just gradually strolling around. They're always indicating some kind of catastrophe or something like that. They found dinosaurs in mud trying to get out of the mud, and they're even breaking their bones trying to get out of the mud, and they fossilized like that. So it's just really interesting to see all those. Here's what I want you to remember about the dinosaurs. Back in 2007, Mary Schweitzer published an article finding soft tissue and proteins in dinosaur fossils. They supposedly died 65 million years ago. There should not be anything soft left in them. Should be no signs of proteins. They all degrade in 100,000 years, 200,000 years. You shouldn't find any kind of soft tissue. But she did. She lost her job. They accused her of being a poor scientist and contaminated her samples with these proteins. But that was just the beginning. And over and over and over again, we're starting to see soft tissue and elastic tissue in these dinosaur bones. This is 2013 article. They found stretchy and pliable tissue in a Triceratops brow. It's just really interesting. And I made a comment there, and that's kind of fun. Protein breaks down rather quickly in bones, especially in hostile environments. So they shouldn't be finding this at all. This group looked at carbon-14 dating of 8 dinosaurs in Texas, Alabama, Colorado, and Montana. It only showed to be 22 to 39,000 years old by carbon-14 dating. So that's kind of interesting. In 1908, this guy found a hadrosaur that had its original skin on it. The skin shouldn't have been there at all. And you could see scales and the skin clinging to the bones. Shouldn't have been there. Shouldn't have been there at all. And so here is soft tissue in the hadrosaur. They found osteocytes, cartilage, collagen proteins, chondrocytes, actual cells. You should not be able to find those in all of those. This came out in 22. This was, the skin looks like a basketball texture on this particular duck-billed dinosaur. Look at all these articles. And even you'll see there at the bottom, they found chitin plus protein from a Devonian scorpion in geology. And that fossil was 359 million years old. How can you find any kind of protein from that long ago? That's my point. They probably didn't live that long ago. You can't have this much soft tissue and proteins found in all these fossils from that happening all there. So probably the 1,500 years before the flood from creation, that's where probably most of the dinosaurs lived. How long afterwards, I have no idea on all of those. I like jokes. Do y'all like jokes? Yeah. Somebody should have separated the rabbits on the ark there when they got off the ark, yeah. This is Mrs. Noah talking to Mr. Noah there. Whose bright idea was it to place the animals alphabetically? There's ants and anteaters right next to each other, yeah. Hey, Noah, do you want the good news or the bad news? Yeah. I like jokes. My son-in-law and daughter were in China for 6 years, He learned the Chinese language really well, and so he said, you got to see their language. And so if you look at this is the word create. It's made out of several symbols, and the symbols are walk, talk, living, dust, man. Isn't that interesting? If you look at this word here, garden, it is dust, breath, enclosure, person. Adam and Eve in the garden. Isn't that fun? It's just really fun. Boat is vessel, 8 people. How many people were on the ark? Yeah, 8 people. This is flood. It is water, total, together, earth, 8. Isn't that fun? So even the earliest language we have has biblical context to it. So that's just really, really kind of fun. Fossils, we find them everywhere. In sedimentary rocks, we only find them in those blankets that cover the earth. And I wish I could illustrate, I wish I had a chart just showing you from the beginning of time all the way up to the top of the time. That's 4.6 billion years. It's only in that top 500 million years that we find fossils, and they're in blankets all over the earth. It's just really interesting if you don't have the figures condensed a little bit down at the bottom. They do that a lot. It's considered to be a major evidence in evolution, but Darwin had a problem with it. He said, I look at the geological record as a history of the world imperfectly kept. So he thought, well, it doesn't work. The fossil record, he knew we found all these animals in the Cambrian time period, but nothing below them. And he knew after time we would find all the fossils down below. Well, it's been 160 years since he published his book, and we still haven't found anything below the Cambrian time period. And so that's Darwin's dilemma. It's Darwin's dilemma. And so you can interpret the fossil record 2 different ways. You can interpret it from an evolutionary context as a display of evolution of species over time, or it can be also interpreted in a biblical context, a record of burial during the time of the flood. And so it's a matter of interpretation on how you look at things and what history you're following. But look at it on there on the left. If it's an evolutionary interpretation, you should see fossils increase in complexity over time. If we went from bacteria, single cell, and we gradually stemmed out from that and gradually got more and more different things to what we have today, it should increase in complexity over time. And there should be a gradual increase in the number of different phyla over time. So you have bacteria, that phyla, and then 2 phyla, then 4, and then 6 or 8, and work its way. You should increase over time. And you should find transitional fossils all the way along the way as well. If you have a biblical interpretation, the vertical order should reflect flooding dynamics and their habitat. As the floodwaters rose, it buried this ecosystem. As they rose again, it buried them further up. Does that make sense? So you should find them like that. And fossils of all the phyla should appear suddenly and fully formed. And you should find no intermediates or no transitions between groups to link them together in evolution. And so that's what we find. We don't find anything down below, and then all of a sudden at the Cambrian time period, almost every animal phyla we know of just appears suddenly. Fully formed, eyes, legs, everything. Eyes, yeah. If I look at, oh, there we go. So I kind of put in there some of the fossils that they have found at the different layers, starting with the Cambrian time period at the bottom. And you can see down here, it's mainly just marine. But you can see marine, the blue goes all the way up to the top. And so the first one was when the waters first started coming over, and it wasn't very much water at the beginning. But then when you get to the 4th or 5th mega sequence, the ocean floor rose, and the continents kind of went down, so lots of water came over. And so you're going to find marine fossils in all the layers up there, and mixed more up in the top with terrestrial. So that's just kind of an interesting way that we find in the fossil record. Okay, each layer has a community of organisms. There's a summary of the order of fossils. The lower layers are dominated by marine, higher layers by terrestrial. And so that's what we kind of looked at all along. For evolution, they interpret it as community changes over time, but from a biblical standpoint, we interpret it as all organisms lived at the same time, just not at the same place. They were at different levels in ecosystems. So it just kind of makes sense that way. These are the Cambrian organisms, the one right at the very beginning. So just really interesting. This one has a whole bunch of legs. This one has 5 eyes. Can you see those? Those are complete, fully formed eyes on that guy. This one, they named it hallucigenia. They can't tell if the legs are sticking up or sticking down. They don't know which ones are the legs, so they named it hallucigenia. That's the biggest one they find at the Cambrian time period. It's about 3 feet long. You can see the feeding arm it has, so they think it was at the top of the food chain during the Cambrian time period. What they don't tell you is they found the same fossils at the Cambrian time period in Xinjiang, China. But these fossils were exactly the same. You can see they got the same legs and arms and eyes and everything else. But the deal is they were found in strata in 10 million years. We went from bacteria to all of that in less than 10 million years. Evolution can't work that way. Evolution is slow, gradual processes of mutation and natural selection. And so it's just impossible to go to all these animals in less than 10 million years. So that's a problem. That's a problem for evolution. And there's no intermediates. There's no intermediates between any of the groups that we can find as we go along. And so we'll kind of explain that a little bit later. So the blue area up there, that's kind of probably what God made in the beginning when he made the earth. And then the layers from the Cambrian time period, the red eras, the area there between the 2 red eras was probably all laid down during the year of the flood. And it just matches. Everything just matches that really well. This DVD is put out by Illustra Media. Illustra Media has lots of things out there that are really good, really good. And this DVD is about Darwin's dilemma. It's got scientists that talk on it, and they talk about the fossil record and how it was a dilemma for Darwin, and it's still a dilemma for the scientists today. This is an interesting fact of what is living today that's already in the fossil record. 79% of the vertebrates that are living today are already in the fossil record. So wouldn't you think that 80% of all intermediates should be in the fossil record? If what's living today is already in the fossil record, surely all these intermediates should be in the fossil record. But we don't find any. Between amphibians and reptiles, we don't find any intermediates. Between fish and amphibians, we don't find any intermediates. They're just not there. Well, here in the 2000s, the last 20 years, they are now coming up with intermediates. Whale evolution, they've come up with all the intermediates in whale evolution, and they now don't consider birds their own category. They think birds are part of the reptiles now, and that they evolved from dinosaurs. And so this has been kind of an interesting thing as it's evolved, because this was a problem for biology, that there's no intermediates between all these groups. Well, in 2006, and I got to tell you this story because it's so fun, Texas Tech had a guest speaker. I graduated from Texas Tech, so I got my notice in the mail. You got to come hear this speaker, Dr. Kenneth Miller. He is the author of the most used science book in high schools in the United States. And so he was going around the country speaking on the topic, why Darwin still matters. So that perked my attention. So I went to hear him talk. There were 1,000 people there. It's just a huge gathering, had all kinds of food. It was really nice. And so his whole talk was, at this time in biology, intelligent design, which I abbreviate ID, intelligent design was making its inroads into the biology world. Because we look at the complexity of organisms, we look at all the machines that are operating in our bodies, and they look like they had to be designed. And so intelligent design was working its way into biology. So he was going around talking about how intelligent design is not true. It's just a religion. It's not scientifically true. And so one of the points he made was, intelligent design people claim no intermediates in the fossil record, But they have found intermediates in the evolution of the whale. And he threw this up on the board. And when he threw that up on the board, everybody clapped and everybody yelled, and yeah, we got intermediates up there. And I took a look at that and I thought, that looks pretty good. Maybe they have found the intermediates. But I've already been studying since 1995. I've been studying on evolution, and one of the first books that came out was written by a guy at the University of California, Berkeley Law School on evolution, and he said you need to have a baloney detector. Well, mine is very well developed. I can notice baloney anytime I see it. And so whenever I see something good, I look for the reference. I looked at the reference. It came from Carl Zimmer's book, The Triumph of an Idea. I got the book, and so I started investigating all of these in the lineup. And so we're talking about mammals going from land into the water to become whales. And so I started with the top guy. They picked Pakistan, Pakicetus. That was a 3-foot dog-like animal found in the deserts of Pakistan. It's called Pakicetus. That's the one they start with. And I'm thinking, why do they start with this dog? And here's why, and it's in a quote. There's a folding in a bone of the middle ear and a positioning of the ear bone within the skull that's absent in other land mammals, but it's a signature for Eocene whales. So they found a bone of the middle ear. There's the bone. It's on the end of somebody's finger. Can you tell that, the fingerprint there? It's a tiny bone they found in the ear of this dog that's got a curve in it that's like a whale ear bone. That's why they picked this particular organism. So that's the beginning of whale evolution. There we go. There's the bones they found. And so there's just a little bone there where the ear is supposed to be. That marks where it's supposed to be. I went to the websites of Gingrich and Thawasson. They are the big guys in whale evolution, and that's the bones they found. And so you notice they drew what it's supposed to look like, or possibly look like. So there's an artist rendition up there in the very top. So that's the beginning of whale evolution. So I went to the next one. What's next in line? Ambulocetus. Why did they pick Ambulocetus? There's the bones that they found. They picked this one because in the ankle bone, down here in the ankle bone, if you look at all the, it's the astragalus bone is what it is. And if you look at all the artiodactyls, like camel and sheep and pig and that group of animals that are hooved, if you look at their ankle bones, some of them have 2 bones or 2 parts of a bone sticking up, and some only have 1 of a bone sticking up on that one bone. And so the 2 bones sticking up kind of makes it look like a pulley. Well, hippopotamus is in that group, and it's got an ankle bone that looks like a pulley. This guy has an ankle bone that looks like a pulley. It's got the 2 bone parts sticking up. That's why they chose this one. So it made the lineup because of that bone. Because it's similar to a hippopotamus spends some of its time in water, and so that's why it made the lineup. There's no mention of an ear bone. You'll never hear the ear bone again. It was in Pakicetus, but they never mentioned the ear bone again. You'll never see the ear bone mentioned anywhere else after that. So that's why this guy's on the lineup, because of an ankle bone. Delanosthenes, they only found a partial skull, some vertebra, and a femur. That's all they found, but that's what he looks like. And I don't know how they can tell that's what he looks like. So that one has been scrapped from the lineup now. They no longer put that one in there, but it was in the first lineup, so I just wanted you to see that. The next one there is Rhodocetus. I want you to look, and I made a circle around his hind limbs. Can you see his hind limbs there? Kinda? Okay, well, that's the lineup. This is the bones they found. Those hind limbs are walking legs. Those are walking legs. But look how they draw it up there at the top. Can I go back? On the chart that they used everywhere, it's just barely, you can barely see those hind limbs. But that is what he's got. Those are walking limbs. So at this point, and it's a 10-foot long dog. And so at this point, I was thinking, I'm just not sure there is evidence for whale evolution here. So let's go to the next one. Actually, the next two. The next two, they only found a skull with lower jaws, cervicals, and an anterior thorax. In Gaviacetus, they only found a slender skull, and they can't even show the picture. I've never found a picture of the skull. But those two have been removed because there wasn't very many parts. They've been taken out of the lineup for whale evolution. So let's go to the next one, Duryodon. There's the bones, definite aquatic animal. You can tell that's an aquatic animal, definite one. So if you compare those two, remember they took out the two in the middle because they just had very few bones. If you compare those two, we went from a 10-foot walking dog to a whale. Do y'all think that's a pretty big gap? That's a really big gap. That's a big gap. It was at this point I realized they're just trying to make this all work, to make it work. That's how they display it, but that's the bones. That's a big difference. So there's a little deception in the way they display it. The next one is a 50-foot long whale. That's Basilosaurus, just really, really big. So I made my own chart. Their chart is on the right, mine's on the left, and I think you can see what I see. I took out the ones where they just had a few bones on there. And so if you look at it, dog, 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 whale, whale. You see a big gap right there? Just a big gap, huge gap. So I don't think they figured out whale evolution. So this is in Nature magazine. I think you can see the same thing. Can y'all see dog, 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 whale, whale? Big gap right there, big, big gap. And notice down here at the bottom, they say the skeletons are not drawn to scale. They made them all the same size so that they would kind of look the same together. They do that a lot. So there's a huge gap between Rhodocetus and Duryodon, and this is just really the bone part. Can you imagine going from land and being able to breathe on land and eat terrestrial things to going into the water? What all changes would have to take place in all of that? But they're strictly going by these bones, and that's just interesting. In all the textbooks today, these are from textbooks today, you can kind of see it. They, of course, are going to put it next to the hippopotamus. They think the whale and the hippopotamus are right at the same place on the evolutionary tree. But then look at it. Dog, dog, whale, whale. You see it? There's always that gap in there. This is another textbook. They show it. Dog, 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 whale, whale. You see that big gap right there? It's just there. This is Freeman's biology book. Dog, 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 whale, whale. It's just really interesting. So I'm just kind of skeptical on when they show something and it's an artist rendition, you need to check out the bones. That's my whole point. Just check out the data, and I think you'll see a lot of things that I see. On another note, the other transition they're showing is from dinosaurs to birds. And so this is really an interesting thing. They have two lines of evidence. One is Archaeopteryx, and so I'm going to go back. One's Archaeopteryx, the other one's these recent fossils in China. So I'm going to show both of those to you. Before I do that, these recent studies here, you can see there's dinosaurs here, and the dinosaurs column all down here, and here's the tree, and there's the birds. So they're trying to link all of these birds to the T-Rex family of dinosaurs, really. It's what they're trying to link it to. And so they use terms on here. They get to decide what characters they look at whenever they're comparing bones or comparing structures. And so that's how they make their comparison. They decide what the characters are that they're going to look at to get them to match together. So that's kind of discouraging. And so there's Archaeopteryx. Over here is what they found. And you can actually see the feathers on the fossil. That's the fossil right there. You can see the feathers there. It's definitely a bird. But Archaeopteryx here, you can see on his wings, he's got claws. and on his beak, he's got teeth. And so I'll go back. When they draw it here, you can see the teeth. They make them very obvious. You can see the claws on his wings, and he's got a really long tailbone. So those are kind of reptilian features, which to me, that would classify as an intermediate in my book. Although if you talk to an ornithologist, which I have done, they will tell you that's just a bird. Some birds have teeth, that doesn't matter. And they say that's just a true bird. So there we go. But that's their intermediate that they have. Now then, they found these dinosaur fossils with feather-like structures. So I thought y'all needed to see these. This is the beginning of feathers on these dinosaurs. So this is Sinomithropteryx, and so those smudges right there, those are the beginning of feathers. So that's the fossil they found. There's another picture of it. You can see right along the back edge, there's these lines. So to me, it looks like collagen fibers, but they're calling it the beginning of feathers. This is Caudipteryx. You can see some lines right there, and you can see this group of lines right there. That's the beginning of feathers. Now, these are from the most used evolution textbook in universities in the United States, is where I got these pictures. So this is the beginning of feathers. Here is Sinomythosaurus. They have a black arrow right here, here, and here that's real tiny, so I put red arrows over them so you can see where to look. That's the beginning of feathers. These smudges here are the beginning of feathers, and that little smudge right there, that's the beginning of feathers. Are y'all convinced yet? Yeah, this is Calundrodromaeus, and this is what they found. Here's how they illustrate it. This was scales, and this is the beginning of feathers on that. So that's their evidence for the beginning of feathers. I kind of believe like National Geographic. National Geographic had an article called Fluffy Dinosaur Raises Questions About the Origin of Dino Fuzz. Here's what they said. Now this is National Geographic. Y'all know that's the most evolutionary magazine there is. They said this: at a basic level, at a basic anatomical level, paleontologists have yet to discern whether the structures on Psittacarus, Triangulum, or Calundrodromaeus, which we just looked at, can truly be called feathers. They're even doubting that they're feathers. And so I am too. I am too. That's a feather. Y'all know what a feather looks up. You probably unzipped them and zipped them several times. That's a wren feather. If we see anything in the fossil record that looks like a feather, we should see some pretty intricate details on it, but we're not. Now here's what's really interesting. This is where they found Archaeopteryx in the fossil record at 150 million years ago. All of these dinosaurs with the beginning of feathers are found from 135 to 65 million years ago in strata up above where they found Archaeopteryx that had a true feather. So that's kind of odd. So what they do is they take this bar, move it over here, and draw a line down here saying, oh yeah, they lived before Archaeopteryx, we just hadn't found them yet. Can you do that? Well, that's what they do. That's what they do. They're at Tech, Dr. Chatterjee at Tech, he found a true bird down at Post, Texas at 210 million years ago. So Archaeopteryx here is at 150. It was way on down there, a true bird. And they'll never talk about that. That's what they do. They just don't bring that out. Yeah.
Just a quick question. How many fossils have they found of Archaeopteryx?
Several.
Okay.
But they only show that one, but they found several.
Okay.
Yeah. I mean, Archaeopteryx looks like a bird. It does have claws. That's kind of interesting on there, but.
I've only ever seen images of the one. Where are the images of the other? Do they still hold?
Yeah, I know. That's the only one I've ever seen too. I don't know, Roy. Yeah. And they're all at 150 million years ago, so I don't know. Yeah, good question. I don't know. So, are these really birds from dinosaurs? I just question it really big. My point is, check out the data. They don't show us all the data. You just need to check it out. This is from a book showing the evolution of mammals. There's Morganocodon. It's the first mammal from a reptile. So here's the reptile evolution to mammals. This is from Kemp's book, The Origin and Evolution of Mammals. Well, Stephen Meyer, who's part of the Intelligent Design Group, he took that chart and looked at the actual sizes of these skulls, and that's their actual size. And he did that in 2007. Yeah, he published that in 2007. It's interesting. The year after that, they took out this one, this one, this one, this one, this one, and this one. They're no longer in the lineup. They just took them out. So it kind of shows you what's going on in that world. So that's just interesting. Man, can I get technical? I don't know. Can I get technical on you guys? I'm going to show this just because it's just kind of interesting. I was talking to a scientist at another university, and he believed in evolution. And I said, "What convinced you of evolution?" And he said, "Well, what convinced me was reptiles going to mammals. The jawbone went up and became, the two bones of the jaw became two of our three ear bones. And that's what convinced him of evolution." Sorry. And so I kind of looked into this. This is what you're going to see in the textbook. Here's a reptile, and you can see it's got multiple bones here in the lower jaw, and it's going to evolve to this, to this, to this, to this, and the lower jaw is only a single bone. In mammals, it's only a single bone in the jaw. But you'll notice, as we go through the evolution, there's an orange and a green bones, those two bones that make up the hinge of the jaw, the orange and the green. And so that would be the articular and the quadrant. So you'll see it there. You'll see it down here, the orange and the green. You'll see the orange and the green there. You'll see the orange and the green there. But the purple and the brown, those are the dentary and the squamosal. You'll see those are getting more prominent. And then when you get to this one, the orange and the green are gone, and there's only the brown and the purple. That's now a new hinge. And it's a hinge where there's a socket that a ball fits into, and that's the hinge on the new socket for mammals. We got a socket out there. So, isn't that interesting? I just find this really, really interesting. I don't know if y'all find this interesting or not. So, I'm going to start here at the bottom and just read through me with this. This is just kind of fun. The mammal-like reptiles first appear in the Carboniferous time period. They became more mammal-like through the Permian and the Triassic as you're moving up. The first real mammals end at the end of the Triassic time period. Then mammals completely disappeared for the next 100 million years during the Jurassic and Cretaceous. You can only find just a couple of cupped hands of bones of mammals during that 100 millions of years. That's all they find. Then, all of a sudden, right there at the 65 million years ago, most reptiles suddenly replaced by a huge variety of land, flying, and marine animals, fully formed: bats, whales, primates, hoof, rodents, carnivores, and monotremes. So that's what's going on. All of a sudden, right there at 65 million years ago, when dinosaurs disappeared, almost all reptiles disappeared. And all these mammals just showed up right at one time. So that's just kind of interesting on all of this. Now then, reptile-mammal transitions are the Morganocodon. That's the one at the bottom of that chart on the right. That's Morganocodon. It's now got the brown and the purple hinge on it. Morganocodon and Cuthnerium, they both have mammal-like jaw components, the dentary and the squamosal, that's the orange and the brown, and reptile-like jaw, the articulate and quadrate bones. They have all the bones there in their jaw. And the reptile jaw is fully functional. The green and the orange, it's fully functional. Also, both had multiple bones in the lower jaw. So those are the transitions, but they've got that orange and green jaw. Another difference, reptiles have a single bone in the ear called the columella, rod-like, connecting the tympanic to the inner ear. Mammals have 3 bones in the ear. So the stapes corresponds to the columella, but the quadrate and articular moved to the ear and became the incus and the malleus. How are organisms able to hear during that transition? I don't know. We have thousands of reptile fossils with 1 ear bone and multiple jaw bones. We have thousands of mammal fossils with 3 ear bones and 1 jaw bone, but no fossils as intermediate. You just don't find it. They just are telling us those 2 bones moved up, became a part of the ear. But you can't find any fossils that are like that. It's just crazy. And besides all of that, you'd have to change the way they reproduce. They started producing milk. They got hair. There's just all kinds of differences between all of those. But they just tell us the bones moved up. They can't show us anything in the fossil record that happened. So I'm a little skeptical. Are y'all a little skeptical? I'm just really skeptical of all that. I have a lot of writing on there to show all that, but that's basically what it is. Last thing, it's only 11:30. We're done. I'm just going to show you this. Gunter Beckley, I really like this guy, Gunter Beckley. He was the curator of the museum in Germany just a few years ago. And when it was Darwin's 200th birthday, which was also the same year he published The Origin of Species, 150th birthday of that, that was 2009, Gunter Beckley decided to make a display in his Museum of Natural History. His display was one of those scales. You know the scales that have the 2 arms out here with the dishes there where you put something and it tips the balance one way or the other? He had one of those scales out on his display. And on one side of the scales, on this plate, he had a lot of intelligent design books, a whole lot of intelligent design books. On this side of the scale, he put Darwin's book, Origin of Species. And he had the scales tipped like this, that Darwin's book has more weight than all of these intelligent design books. So he was really proud of his display. So before he opened up on that day for the celebration, he got to thinking, you know, I probably ought to read these books. They're probably going to ask me what's in those books of intelligent design. He read the books, and it convinced him that we were designed. All the evidence shown in those books was convincing to him, and it made sense to him. And so he became a person that's talking about intelligent design now. He got fired from his position, but he's working, well, he died last year, but he was working with a group of intelligent design people. And he did a YouTube that was really good on the fossil record. He knows his fossils really, really well. And I'm not going to go through every one of the slides here. I'm just going to show you the end slide and we'll be done. But he showed all the different places in the fossil record. So the Cambrian time period is down here, is the Cambrian time period. And all of these fossils, every one of these fossils, he said they appear in the fossil record, but they can't connect them to any precursor down below. There's nothing to connect them to. But this is a chart. The chart you're looking at is made it's from a biology textbook, and you can see everything's connected by lines. But he said, you can't connect any of these organisms all along the way. You just can't connect them. But they connect them. They put the lines in there, but you can't tell from this what organism is connected to what. They just draw the lines to make you think that they've got it figured out, but they don't. So I really encourage you to hear Gunter Beckley. He does a good job in talking about that. So the fossil record, that's usually how they present it now. That's a 2024 textbook. That's how they present it. And you really can't tell what's connected to what in there because they can't connect things together. And so they're struggling with that a lot. So, is this making sense to you guys? Yeah, just got to be careful, check out the data and what's being presented, and go from there. Teach our kids to check out the data, look at it. So, questions? You are hungry, I know. I am too, yeah. So, Where's Josh? There we are. Yeah.
Whenever we're ready, we can go back there and set up and pray for food.
Okay. Sounds good to me. Sounds good to me. Thank y'all.